Hi everyone. Today we're going to study derivative of inverse trigonometric functions. First, let us have a review about inverse function. If f of x is defined from a to b, such that f of x equals y for all x an element of a, where it is a bijective function. Bijective means the function is one-to-one and onto. Then there exists the inverse function f raised to negative 1 power. This is the symbol for inverse, defined from b to a, such that f inverse of y is equal to x for all y an element of b. Let us also review about inverse trigonometric functions. For the trigonometric function, let's say y equals sine x. If we want to get the angle x, we compute for x equals sine inverse of y. And it follows that the inverse function becomes y equals sine inverse of x. In other books, you will see y equals arc sine of x. Let us study now derivative of inverse trigonometric functions. Let us write the formula starting with d over dx of sine inverse of x. This is equal to 1 over the square root of the quantity 1 minus x squared. By chain rule, the formula becomes like this, where u is a function of x. Second, d over dx of cosine inverse of x. This is equal to negative 1 all over the square root of the quantity 1 minus x squared. By chain rule, the formula becomes like this. Take note that there is a similarity in the derivative of sine inverse and cosine inverse. The difference is the negative sign in the cosine inverse. Third formula, derivative of tangent inverse of x. This is equal to 1 all over 1 plus x squared. By chain rule, the formula becomes like this. Fourth formula is d over dx of cotangent inverse of x. This is equal to negative 1 all over 1 plus x squared. By chain rule, the formula becomes like this. Take note also that there is a similarity between the formula of derivatives for tangent inverse and cotangent inverse. The difference is the negative sign for the cotangent inverse. Next is the derivative for secant inverse x. This is equal to 1 all over the absolute value of x times the square root of the quantity x squared minus 1. By chain rule, the formula becomes like this. Sixth formula, the derivative of cosecant inverse of x. This is equal to negative 1 all over the absolute value of x times the square root of the quantity x squared minus 1. By chain rule, the formula becomes like this. In here, take note of the similarity of the formula of derivatives for secant inverse and cosecant inverse. The only difference is the negative sign for the cosecant inverse formula. Let's see this example 1. Show the steps of finding dy over dx for y equals tangent inverse of x. First, rewrite this function to be x equals tangent y. And from here, we're going to take derivative by implicit differentiation. It means we will show that we will take the derivative of both sides with respect to x. And then, let us evaluate the derivatives respectively. The derivative of x is 1. The derivative of tangent y is secant square y times dy over dx. We want the value for dy over dx. Let us divide this equation by the coefficient of dy over dx, that is, the secant square y. So the value of dy over dx now becomes 1 all over secant square y. Take note that the secant square y equals 1 plus tangent square y. We will substitute this value in here. So dy over dx is equal to 1 all over 1 plus tangent square y. We want to take the value of this function of y with respect to x by looking at our equation here. X equals tangent y. If we are going to square this equation, we will have the tangent square y equal to x squared. So we are going to substitute this tangent square y into x squared. Our final answer now is dy over dx equals 1 all over 1 plus x squared. Example 2. Find dy over dx for y equals x sine inverse x plus x squared cosecant inverse x plus 3 tangent x. For our solution, take note that there are some functions here which are products of two functions. This first function and the second function here. So we will apply the product formula. So dy over dx will be like this. For this function, the derivative now is we take the x times the derivative of the second function plus we copy the second function times the derivative of the first function. Then plus the derivative of this function is we copy the x squared times the derivative of the second function here plus we copy that second function times the derivative of the first function. Then plus the derivative of 3 tangent x is now 3 secant square x. Let us simplify this line by taking the derivatives respectively. So we have the derivative of sine inverse x is here, that is equal to 1 all over the square root of the quantity 1 minus x squared. The derivative of x is 1. The derivative of cosecant inverse x is negative 1 all over absolute value of x times the square root of the quantity x squared minus 1. The derivative of x squared is 2x. Simplifying further, this line now becomes like this. In the next line, we will simply remove the grouping symbol, and we will have this as our final answer. Example 3. Find dy over dx for the function x sine inverse of y plus y sine inverse of x equals pi. For our solution, we can see that this function here is an implicit function. So we will apply implicit differentiation. At first, let us show that we're going to take the derivative of both sides of the equation. So here is d over dx of the left side equals d over dx of the right side. On the left side, we will take the derivative of each function. Let us now begin our differentiation. On the left side, we can see that each function is a product of two functions. So we will apply product rule. For the first group here, we have now x times derivative of sine inverse of y, plus we copy that second function times derivative of the first function. Then plus, we take the derivative of the second group here, we copy the y times derivative of sine inverse x, plus we copy that second function times the derivative of the first function, equals the derivative of the right side, which is pi, and we know that pi is a constant. So derivative of a constant is 0. The next step is we're going to evaluate the derivatives respectively. So derivative of sine inverse of y is now 1 all over the square root of the quantity 1 minus y squared times dy over dx. Derivative of x is 1. Derivative of sine inverse x is 1 all over the square root of the quantity 1 minus x squared. Next, derivative of y is 1 times dy over dx. Now let us simplify this line into like this. This expression here becomes like this. This expression is now simplified into this. This expression is simplified into like this, and also this one here becomes like this. On this line, we're going to combine those terms with dy over dx in one side of the equation. It means those terms without dy over dx, we will put them on the other side. So look at the two middle terms here. There is no dy over dx on each of these terms. So we are going to transpose this to the right. Of course, the sign must be changed. So this line now we can rewrite like this. Now, the dy over dx is common for the terms of the left side. We're going to factor out the dy over dx. So we have next step to be like this. For our next step, we're going to combine these two terms into one single fraction. We will do the same on the right side. So it will be like this now. The next is we will isolate dy over dx by dividing this equation by this fraction. It means to say our dy over dx will be equal to this fraction here all over this fraction. Further, we can show that our dy over dx is equal to this fraction we write here times the reciprocal of this fraction. This is our final answer. Example 4. Find the derivative of y equals x squared cosine inverse x. Note that the function is a product, so we will use the product rule. We assign the x squared to be the u and the v is the cosine inverse x. Now, the derivative, that will be, we copy the u, that is the x squared, times derivative of the cosine inverse x. So we write here negative 1 over the square root of the quantity 1 minus x squared, plus we copy the v, the cosine inverse x, it's here, times the derivative of u, that is x squared becomes 2x. Now simplifying the first group plus the second group, we have now negative x squared over the square root of the quantity 1 minus x squared for the first group, plus 2x times the cosine inverse of x. Take note that in the second group, this 2x must not be multiplied with the x in here. So, we put this 2x in front of the cosine inverse function. Example 5. Find the derivative of y equals sine inverse x all over 2x minus 3. Note that the function is a quotient or fraction. Therefore, we are going to use the quotient rule. Let's start taking the derivative. First, we copy this 2x minus 3, we put as denominator with power 2. Then, the 2x minus 3, we will copy on top, to be multiplied by the derivative of sine inverse x, and that is 1 over the square root of 1 minus x squared. Then, minus, we copy the sine inverse x multiplied by derivative of the denominator. So that is 2. Now we simplify our numerator. So we have 2x minus 3 all over the square root of 1 minus x squared minus 2 sine inverse x. All over, the denominator here will just be same. Now, let us simplify our numerator. Let us combine this fraction minus this 2 sine inverse x. What we're going to do is to multiply the 2 sine inverse x by a fraction, whose numerator and denominator is the same with this denominator here. So we have like this. And then, we can see that the two fractions are like. Now, we can combine them. So we have 2x minus 3 minus 2 sine inverse x times the square root of 1 minus x squared all over the square root of 1 minus x squared all over the square of the quantity 2x minus 3. At this point, we can simplify this complex fraction into like this, meaning this numerator as a fraction we copy as is, multiplied by this denominator that we flipped upside down. So we have this 1 over the square of 2x minus 3. Then simply we multiply the two fractions. So in the denominator, we can simply put together the two functions. So it becomes like this. This is the final answer.